Okay, so let's start the last part of Unit 1 where we are going to study the technology Microsoft Hyper-V. It's one of the technology example. So if you have a question on Microsoft Hyper-V, you'll have to answer as per this content. Okay, so let's see. Microsoft Hyper-V. So Hyper-V is an infrastructure virtualization solution developed by Microsoft for server virtualization. So here we have mentioned what type of virtualization. It's an infrastructure. So infrastructure is same as the hardware. So when we say hardware, it means processor, memory, hard disk. So that virtualizing anything on top of that is infrastructure virtualization. So this product Hyper-V was developed by Microsoft. So Hyper-V uses a hypervisor based approach to hardware virtualization, which leverages several techniques to support a variety of guest operating system. So there is an hypervisor, and it may use different types of virtualization like para-virtualization or hardware-assisted virtualization. So different techniques. Hyper-V, so if you need Hyper-V, it is shipped as part of Windows Server 2008 R2. So here we notice it is part of the server operating system, and we don't need to install or separate hypervisor. It is part of the operating system. So to increase the performance of virtualized environments, a new version of Windows Server 2008 called Windows Server Core has been released. So Windows Server Core is specializing in good performance of virtualized environments. Another component that provides advanced management of virtual machines is System Center Virtual Machine Manager SCVMM 2008. So even this product comes with its own Hyper-V component, which is a virtual manager, which is a hypervisor. So this is a component of the Microsoft System Center suite, which brings into the suite the virtual infrastructure management capabilities for an IT lifecycle point of view. So if you want to do virtualization, Microsoft Hyper-V is one of the ways or one of the product you can use to do virtualization. So here we see Microsoft Hyper-V architecture. Okay, so what do we see? So we see there's a hardware right at the bottom. There's a processor, there is a memory. So right at the bottom there's hardware. On the top of the hardware we have hypervisor. So we don't have an operating system. So this is a type 1 hypervisor which runs directly over the hardware, and it runs using the ring based architecture in ring 1. As we know, ring 0 has the maximum privileges, and hypervisor runs in ring 1. So the ring 0, usually the kernel of the operating system is what runs usually in ring 0. And if you notice, all the user, so these are all kind of virtual machines been created, and they are running in ring 3, so it has lesser permissions. So all the calls are going through the hypervisor, and nobody can access the hardware directly. So how does it work? So Hyper-V uses partitions to support multiple guest operating system. So usually you must have partitioned in hard disk, and each partition you may be using to store your data, or maybe using it to install a totally new operating system in each partition. So whenever Hyper-V wants to create a new guest operating system, the first thing that it does, it creates a partition, and on that partition is where the new guest operating system is installed. So here we see there is the architecture consists of 4 virtual machines, except for this one looks little different. So this is called the parent partition, and everybody else is called the child partitions. So hypervisor manages all the partitions. They're using the same physical machine underlying the hypervisor, and this infrastructure is shared between 4 virtual machines. HyperV takes control of the hardware, and the host operating system becomes a virtual machine instance. So this is very important. So even though Windows operating system is installed, it is installed on the parent partition, but who is controlling it? Hypervisor. So hypervisor is given a higher control, and if you notice, hypervisor aware kernel, the kernel of the operating system is still running in ring 0, and the kernel can do all execute all the instructions, especially the privileged instructions. So but who's controlling it? The hypervisor. So not only the hardware is controlled by HyperV, which is this hypervisor, but also the host operating system. So it has this parent partition has is the main partition which controls all the other partitions. So as a result, HyperV becomes type 1 hypervisor because it is running directly over the hardware and it is controlling the operating system internally. Hypervisor is not running over the operating system, but operating system is running within the hypervisor's control, and hence it is a type 1 hypervisor. The parent partition is also called the root partition, is the only one that has direct access to the hardware. So if you see, hypervisor first of all controls the hardware, and hypervisor controls the operating system, and this operating system has a kernel which has ring 0 which can run directly on the hardware, but it can execute the commands only if a permission has been given by the hypervisor. The operating system is in total control even though it has ultimate access to the hardware. The parent partition runs the virtualization stack, hosts all the drivers required to configure the guest operating system, and creates child partitions through the hypervisor. So hypervisor makes the decisions whether the partitions have to be created or not, but ultimately it uses the kernel of the operating system which runs on parent partition. So parent partition has all the drivers, device drivers to access. So device drivers, you can have device like USB. So you may have a common USB, and it can be accessed by each and every virtual machine. So even all the devices can be shared, but the device driver is installed actually in the parent partition, and the parent partition has all the operating system, has the device drivers, the input output stack. So let's see, and let's move forward. Child partitions are used to host guest operating systems. So you might have a Linux here, you might have a Ubuntu here, you might have a Windows, another Windows operating. You might have a Windows XP here and a Windows 7 here. So let's see. I'm not sure if we can have Windows 7 here, because as we said, hypervisor runs using Windows Server 2008. So the parent partition needs to have one of the operating system which contains the HyperV product. Okay. HyperV hypervisor. So let's look at the hypervisor now. Now hypervisor is a component that directly manages the hardware. So we know that hardware is something like processors and memory, but it has 6 components. So you see it has HyperCalls, MSC, APIC, scheduler, address management, partition management, HMASAP. You might have to remember that. HMASAP. Okay. Okay, where are we? Oh yeah, it is. So we have HyperCalls interface, memory service routines, advanced programmable interrupt controller, scheduler, address manager, and partitions. Hypervisor executes in highly privileged mode and hence able to support legacy operating system that has been designed for x86 hardware. Since Hypervisor is in full control, it can manage the old 32-bit systems like x86 as well as x64, and so it can make sure that sensitive instructions are not executed unless and until it is allowed, so it is more secure. The HyperCalls interface, so this is one of the components of Hyper-V. This is an entry point for all the partitions of executive sensitive instructions. So anytime system calls have to be made, it has to pass through this HyperCalls. It is called HyperCalls because the hypervisor is executing them. So it uses para-virtualization approach to allow direct calls to OS for non-privileged, non-sensitive instructions. So what is para-virtualization? Para-virtualization is where you modify the operating system so that operating system doesn't has to directly go to hypervisor. So if the hypervisor is making if there is a non-sensitive, non-privileged instruction which does not bring harm to the computer, the kernel can directly call the hardware instead of going through the hypervisor layer. So yes, so there are certain instructions which are non-sensitive, which are non-privileged, that can be directly executed over the hardware. Memory service routines. These are set of functionalities that control the memory and the access for partition. So even though there are 4 partitions, the memory is common over here, the physical memory. So you might have a 4 GB memory, but that has to be shared between all these virtual machines. So who's going to manage that is the MSRs, memory service routines. HyperV uses hardware-assisted virtualization for input-output memory management unit to fast-track access to devices from partitions by translating virtual memory addresses. So we have a common set of devices attached to this computer which is shared between all these virtual machines, and so what does it say? It uses hardware assisted virtualization. So there's a firmware which is in between something like an Intel VT or an AMD Pacifica, which is tuned for carrying out virtualization operations. So what is a virtualization operations? It can be same as physical machine, but except in this case you have so many input output commands from each and every virtual machine on this running over this hypervisor. So it's like running 4 machines, and somebody has to manage, and hardware assisted virtualization helps you do that faster. Advanced Programmable Interrupt Controller. So what does this do? This component represents the interrupt controller which manages the signals coming from the underlying hardware when some event occurs. So every time there is an hardware event, especially when there is a trap. So when will the trap happen? The trap will happen when a guest operating system tries to execute a privileged instruction which it is not allowed to. So let's say you download a virus on your guest operating system which tries to delete the file. So there might be, and that's a privileged instruction, and it might raise a interrupt which the hardware will catch. So the hardware will not execute that instruction. It will be caught and given back to Advanced Programmable Interrupt Controller. Each virtual processor is equipped with synthetic interrupt controller, which constitutes an extension of the local APIC. Okay, so each virtual machine will have a virtual processor, and there will be an interrupt controller, synthetic interrupt controller, so which is like a virtual interrupt controller for each virtual machine. The hypervisor is responsible for dispatching when appropriate the physical interrupts to the synthetic interrupt controllers. So if there was an instruction which was not allowed, the APIC will ultimately give it to the synthetic interrupt controller of the corresponding virtual machine. So let's look at the scheduler. This component schedules the virtual processors to run on the available physical processor. So since you have a single processor, or maybe a single or multiple physical processor, the virtual processors are sharing this physical processor, and the scheduler is helping the schedule the execution of all the processing on these processors that is available. The scheduling is controlled by policies that are set by the parent partition. So you might have some priority as far as who gets the processor. So the parent partition usually will get the maximum priority to run the instructions on the processor. So you have the address manager. The component is used to manage the virtual network addresses that are allocated to each guest operating system. So even though this physical machine is one and it will have its one IP address, you're creating 4 different virtual machines on this, and each one of them will have its own IP address. So somebody has to manage this network, and that is managed by the address management. Partition manager is in charge of the performing partition creation, finalization, destruction, enumeration, configuration. Its services are available through the HyperCalls interface. So basically this component is responsible to create the partition, but who makes the decision of creating this partition? It is the hypervisor along with the parent partition. So what are Enlightened IOs? So if you notice here, you see a VMBus. So it's a common communication channel. So whenever there is data to be shared between one virtual machine to another virtual machine, it doesn't have to go back to the physical hardware and through the hypervisor and then come back. It can simply use the bus to transfer the data to the next virtual machine, or exchange the data using the VMBus. So you can think of VMBus as exposing a common port through which all the virtual machines communicate. So Enlightened IO provides an optimized way to perform IO operations, allowing guest operating system to leverage an inter-partition communication channel called VMBus rather than traversing the hardware emulation stack provided by the hypervisor. So VMBus allows you for horizontal communication instead of going back to the hardware. So that saves time, right? It doesn't have to go through a hypervisor, and then the hypervisor makes the call to the physical data, and then it gets back. You can, if you want to pass the data between 2 virtual machines, you might as well use the VMBus. So some of the common programs that like managing a USB. So we want to inform one virtual machine that you have to wait for the USB, and the other virtual machine will get access. So all this kind of communication can happen using the VMBus exchange. It's called the inter-partition communication channel. VMBus is an inter-partition communication channel that is used to exchange data between partitions, and it is utilized mostly for the implementation of virtual device drivers for guest operating systems. Enlightened IO has three main components. So how does Enlightened IO works? Using VMBus, and using VSPs and VSCs, virtual service providers and virtual service clients. So virtual service provider is the main component which uses the VMBus to transfer information between various virtual service clients. So all the child partitions, which is this second one, third one and fourth one. So in this case the fourth one is not using a VMBus, so it is a Enlightened child partition. Since these two partitions are using VMBus, it is a Enlightened child partitions. And how they manage, how is the communication managed? The VSC and the VSP, the virtual service provider, which is in the parent partition, communicates with the components of VSC's components, and which in turn uses VMBus. VMBus implements the channel and defines a protocol for communication between partitions. So VSPs are kernel level drivers that are deployed in the parent partition. So VSP is installed in the parent partition and provides access to the corresponding hardware device. So if you want to read, so hardware device can be a hard disk, and if reading has to be done and the data has to be shared, the VSPs will communicate with the VSCs using the VMBus. This VSPs interact with VSCs, which represent the virtual device drivers, also called synthetic drivers. So synthetic is a word similar to virtual, which means it is not real. It is created to operate specifically for each virtual machine. So operating systems supported by HyperV utilize this preferred communication channel to perform input-output for storage, networking, graphics and input subsystems. So if you have a Enlightened child partition, it will run faster. Otherwise, if you have an Unenlightened child partition, it will run slower because it has to go through the hypervisor to access the hardware. So this specific feature is something which is very important for you to explain when you're explaining the HyperV technology. The parent partition executes the host operating system and implements the virtualization stack that complements the activity of the hypervisor in running guest operating system. This partition always hosts an instance of Windows Server 2008, which manages the virtualization stack made available to the child partition. So as we said, the parent partition will have Windows Server 2008, but it will be controlled by the hypervisor. This partition is the only one that directly accesses the device drivers and mediates. So all your devices are ultimately accessed by parent partition. If the child partition needs access to the device drivers, it has to go through the parent partition, in which we have the VSP components, and these VSP components will actually interact with the operating system to get the access to the device drivers. The parent partition is also the one that manages the creation, execution and destruction of child partition. So we mentioned that in the hypervisor we have partition management, and this partition management will communicate with the operating system in the parent partition for creating the partitions, all the child partitions. So if you want to create a child partition, the operating system will use this partition management components to do so. So how it does, so there is a the parent partition has a component called virtualization infrastructure driver. So this driver is useful to create the partitions. It has access to hypervisor and allows the management of virtual processor. Virtual processor is virtual processor assigned to each virtual machine. So if there are 4 child partitions, then there are 4 virtual machines, and there will be 4 virtual processor and 4 virtual memories. For each child partition, a virtual machine worker process is instantiated in the parent partition, which manages the child partition by interacting with a hypervisor through the VID. So virtual machine, so for if there are, in this case we have three virtual child partitions, so which means three child virtual machines. So for each one of them there will be a VM what is the virtual machine worker process. So there will be four worker process or four worker process in this case, one for the parent partition and three for the child partition. So all these processes will be running in the parent partition, and through that process there is a communication going on to all the virtual machine. Is that through that process the virtual machines are controlled. Child partitions are used to execute the guest operating system. These are isolated environments that allow secure and controlled execution of guest. Two types of child partitions exist. They differ on whether the guest operating system is supported by HyperV or not. These are called enlightened or unenlightened partitions. So even before you install the hypervisor, you might have already created two partitions, and that partition is unenlightened. Then later you would have installed HyperV and created three partitions which uses HyperV, and hence it became automatically enlightened. So you might have a combination of enlightened partitions as well as unenlightened child partitions. The enlightened partitions can benefit from Enlightened IO. So as we said, Enlightened IO is nothing but using the VMBus to communicate communicate and coordinate and manage faster between the virtual machines, enlightened virtual machines. The unenlightened virtual partitions are executed by leveraging hardware emulation from the hypervisor. So that's it with this presentation. We complete unit 1, and we'll soon be starting unit 2. So thank you.